So in this video, I'm going to discuss the minimum moves to spread stones over grid problem, which offered in today's LEETCODE challenge. So if you have any doubt regarding this, you can ping me up on Instagram. Even you can join my Discord server. I will provide both the links in the comment section and pin them. The problem statement is very simple. You're given, just wait 1 second. Okay. So you're given an array of size, a 2D array of size 3 into 3, and the sum of all the elements over here is 9. So you have to spread 1 to all the cells. So basically what you need to do is wherever you find a 0, you have to make it 1, right? So if you find a 0, basically for this case, to make it 1, so you have to borrow 1 from 2, right? So from here 1, 2, 3, right? So it takes 3 steps. For this there is a 0 over here, so you can borrow 1 from 3. Now 3 becomes 2 and this becomes 1. Then you can borrow 1 from here, so this becomes 1, this becomes 1. So basically 1 step, 2 step, right? And for this 1, 2, 3 steps, 1, 1. So 4 steps, right? So basically there were 4 steps. Now the approach is you have to use recursion for this. Okay, recursion for this. Now so for right, for recursion there are 2 cases. One is the base case, another is the normal case. Okay, that is the recursion case. So first we are going to discuss the base case, that is 1 1 1 1 1 1 1 1 1. So if the grid is this, so you have to return 0, right? And for the recursive case, okay, recursive case, you have to consider for all pairs I comma j. Inside this you have to again consider for all pairs, let's say k comma l, okay, k comma l, if grid of I of j is equal to 0, as like I mentioned that you have to only change it when it is equal to 0. Okay, so if it is 0, then you have to make grid of I of j plus plus and grid of k of l minus minus only, okay, minus minus only if grid of k of l, so sorry, so let me rewrite this. Okay, rewrite this condition over here, that is if grid I comma j is equal to 0 and grid of k comma l is greater than 1, right? So then only you can subtract 1 from here and add it over here, right? So you have to subtract 1 from here and add that 1 to here, and then so let's say so there was a int result which was initially 10 to the power 9, because that is a very big number. Okay, so initially it was 10 to the power 9. So now you have to make result is equal to minimum of result comma distance between these 2 points, okay, plus whatever the function was. I think the function was minimum moves something. Okay, minimum moves grid. Okay, and once you are done with this, so you have to like change this values, that is grid of k of l. So it was minus minus, so now you are going to make it again plus plus and grid of I of j minus minus. Okay, so how you are going to find the distance? The distance is nothing but the absolute value of k minus I plus absolute value of j minus l. Okay, k l j I. So this is the distance thing. This is the formula for the distance thing. So once you're done with this, so you have to return result. Okay, return result. So this is basically using the perfect brute force, right? That is, you're going to check that if I borrow a 1 from whatever position I want, and then you have to return that 1 and check if that is a minimum move, that is the best possible solution or not. Okay, and if that is not the best possible solution, so this minimum thing is already there, right? This minimum thing is already there. So basically this is how you have to do it. Okay, so this is recursion. So the recursive the recursive formula is this. Okay, and distance is equal to this. Okay, so this is how you have to do it. That's it from my side. Thank you.